This video demonstrates how to do photometry with the ASTAP program using SeeStar images. If you start up the program, you will see the viewer. For photometry, you have to open the stack menu by pressing the summation button. In the stack menu, you have several tabs for lights, darks, etc. But today we are interested in photometry. Let's browse for the files. A SeeStar owner John sent me a bunch files, all taken with 10 seconds exposure time. You can click on the files to display them in the viewer. You can see it is a raw one-shot color image or frame. It contains only gray levels. There is no color. We will remove the red, green and blue sensitive pixels from the raw frame and put them in separate files representing the red, green and blue channel. We don't convert the image to color, that is the wrong approach. But let me show how you can convert it into an color image. If we select Do Mosaic, it will be converted to color image. The stars are pretty white, not much color in this image. But we will not convert the color, we will just separate the red, green, and blue sensitive pixels. Let's have a quick look to the guideline. The guideline says to collect frames with an exposure of about 10 seconds and with a half flux diameter of around 10. And you can test that in ASTAP, so let's do that. We display one image again. Normally you can use the shortcut button F4. We will access it via the menu Image Inspection. There we have a button, Tilt F4. Just press this button. Or just press the key F4. In the bottom is reports the median half flux diameter is 10.9. That is required for accurate measurement. By defocusing, the star profile is more flat. By defocusing, it illuminates more pixels, compensating for unequal sensitivity. It prevents that the peak of the star illuminates mainly a single red or blue pixel. So if the flux is spread out, the measured value will be more stable. We have loaded these files in the Photometry tab. We have to check some settings. We have selected the method, Measure All Annotated. We can select different menus. But today we will use option Measure All Annotated. I select Online Gaia since we measure in 3 colors. And we select for the annotation the local database down to magnitude 13. We have set the aperture to 1.8 and the annulus diameter to 6 HFD. One important thing: saturation level. The stars should not be saturated. You can set the maximum level here. Check the checkmark and set the value at 60,000. Above this value, saturation will be reported. If you uncheck the checkmark, then the saturation level is set by the brightest value in the image. Because we don't have many stars in this image, our stars of interest could set the saturation level and trigger saturation warning. So we fix at a manual value of 60,000. Pictures typically reach values up to 65,000. By setting it at 60,000, saturation will be detected prior to real saturation. The next step is to check the frames by pressing the Analyze button. Let's do that. Analyze will take some time. The progress is visible at the left top of the window. I will pause the video for a moment. The analyzing is now ready. We have a lot of data. Image dimensions are indicated here. Wide, height, filter. The SeeStar telescope reports as default an infrared cut filter. Columns for half-flux diameter, number of detected stars, solved image. I will now press the Analyze Plus button. Since it takes some time, I will pause the video. Okay, the analyzing has been done. Let's have a look to the details. The column background value could be interesting. We can sort on the background to see if there is a bad image. There is some variation. The lowest value is 449. The highest value 769. But it still looks good. The background is typically dependent on the altitude of the imaged object. We can also check the half-flux diameter, so let's sort on half-flux diameter. So the maximum is 11.7 and when I scroll up it's 10.4. That looks good. I think these images will do. The first step is to separate each image into separate red, green and blue images. To recap, we have collected images of an exposure of about 10 seconds. They are a little defocused to reach a star half-flux diameter of around 8 to 10. Files are loaded in tab Photometry. We have set some settings in the program. We have pressed the button Analyze Plus. By sorting on columns, we checked for bad files in the list. Now the next step is to extract the red, green and blue channel from the selected images. This is done with the pop-up menu. So this is step 4. You have to select all the images. We can do it with shortcut Ctrl+A or with the pop-up menu. Select the following menu. Extract green, blue and red channel of the selected raw files. OK, let's select and start the separation. This will take some time because we have 913 images. I will pause the video again and return when it's finished. OK. The separation in red, green and blue files is ready. So what has changed? You can see that the width and the height of the images has halved. The width is now 540 pixels and the height is 960 pixels. Also, the filter value has changed from the generic infrared cut to TB, which stands for blue, TR for red and TG for green. You can also see that the background is different. The red frames have the highest background value. Okay, Let's see how they look. In the viewer, you can still see the previous image, which dimensions 1080 times 1000. 920 pixels are indicated in viewer status bar. That's the original size. Let's now click on one of the new files. You can see that the stars are better visible. The background is uniform and the size is now 540 x 960 pixel. Let's have a look to the red image and green image. So that looks all good. We have now plenty of files. We have now 3 times more files. Photometry using these files is possible, but the signal-to-noise ratio is not so good. The exposure time is only 10 seconds. So the next step is to stack these files in groups of 10. Then we'll get an equivalent exposure time of 100 seconds. Let's first go back to the guideline. By selecting all raw files and select the pop-up menu Extract, we have extracted the red, green and blue channel of the selected raw files. That was step 4. Now let's go to step 5 and it says stack in groups of 8 or 10 images using the same pop-up menu. Okay, let's do that. This time you don't have to select them all. You can just click with the right mouse button and select Stack all files in groups, mode average. We type 10 for groups of 10, so we will combine 10 images each time. You immediately see that the files are sorted on filter and as secondly on date. This will take some time and generating many messages. Darks are not required for the SeeStar. The progress is visible by this vertical bar. When this bar is at the bottom, it's ready. I will pause the video again till it's finished. All images have been stacked. If we look to the column Exposure, you will note that the new exposure time is not always 100. Some are 90, some even a 50-second exposure. This was due to an align problem. And I have fixed it by switching to another alignment method. Normally I use star alignment, but this time it was not so successful. Some images were skipped. So I switched to astromatic alignment, and then most images are aligned and stacked. Next time it will be better to aim for a little smaller half-flux diameter. If there are more stars visible, then stacking should be reliable. So that was a small problem, but we do have enough images for photometry. The next step is to press the play button. This is the play button. It will go through the images, annotate and measure the stars. Let's have a look to an image. So if I click on a file to display, you can see that the program annotate only 3 stars. Green text indicates reference stars with their documented magnitude. This image is a blue image. TB stands for blue. It indicates the star blue reference magnitude. This is our variable star, W-UMA. If I click on a green image, you get the Johnson V magnitudes documented. The Johnson V pass band is very similar to our camera green channel. So let's press the play button. On the right side, columns will be filled with measured data. You have a magnitude value column, signal noise ratio value, and a flux value column. Same for the next star, the 0 BPQ 651 and the 747. This will take some time. I will pause the video till it is finished. We are almost ready. You can see that the images are aligned. So the stars are steady and the sides shift for each frame. The stars are kept at the same position. Now we have a large list of measured magnitudes. And now we can go to the report window. So let's press on the AAVSO report button. This is the report window. As you can see, we have a nice curve from the variable star WUMA. So the variable star points are marked with a round dot. This is the red channel, the green channel, and the blue channel. Here you can select, unselect the variable star. This is the comparison star. Note it has about the same color, BV, as the variable star. This is our check star. The comparison star, that is our reference. Reference star points are indicated by a small cross. And of course, because it's the reference, this is a steady line. So we have a red, a green, and a blue reference line. The check star is like the variable star measured, and there is some variation in the check star values, visible in the red, green, and blue channel. Some measured values look like an outlier. Maybe in a bad image, you can move the mouse pointer to that point. Then you can call up the pop-up menu with the right mouse button. Using the graph time, then program will select the corresponding images in the list. So, you can see the selection has moved. The only problem is that there are red, green, and blue image having the same time stamp. We want to inspect the green channel. Let's look to the Julian date. Let's unselect the green channel. See, that works. This image is causing the small outlier in the curve. We can inspect the image by just double-click on the file. This is the image. Maybe the stars are a little oval. Somehow this image is a little out of line. Okay, I think we have to accept it. The next step is to produce the report. You can enter your observation code to upload it to the AAVSO. You can change the delimiter in the report. You can also apply transformation. I will discuss transformation in another video. Press the button, Report to File. The report and graph are stored. Default, they can be stored to the same location as the images. The report is also visible at the bottom of the report. Let's go through the checklist again. First, you have to take a little unfocused images with an exposure time of about 10 seconds. The measured half-flux diameter around 8 to 10. Load these images in the tab Photometry of the Stack menu. Shortcut Ctrl+A. Review the images with Analyze button and then extract the red, green and blue channel with the pop-up menu. Next step is to increase the exposure time by stacking them in groups. To get an exposure time of 100 seconds, the group size should be 10. So 10 images of 10 seconds exposure is equivalent to 100 seconds exposure time. Press the play button to measure stars in the images. The star measurements are reported in the right section of the tab. Then the final step is you press the AAVSO report button. And if it's all correct, press the Report to File button and upload the report file to the AAVSO. That's all for this video. Thank you for your attention.